Hello everyone, I'm here to give you an introduction to numerical modeling. This is take 3. I've got 5 minutes to do this, so here we go. Here's your homework. Double click on the carbon dioxide data Excel file and you should bring up Excel, and it should look something like this. And what we're going to do today is model some data, atmospheric CO2 and some pH in the ocean. So here's the sheet that should come up, and it should have atmospheric carbon dioxide down here at the very bottom left-hand corner and ocean pH. You'll highlight the data with a left click, 1, 2, and go up here and insert. And if at any point in time you need to stop the video and kind of play with things, you can. You can start and stop this video whenever you want. And I'm going to insert a scatter plot, so these little dots, and this means it's an XY graph. And that's how easy it is to make a chart in Excel. Now, I don't like the way this chart looks. This is my CO2 data in parts per million. That's a unit of CO2. So I'm going to left double click on it, double click it, and I'm going to make this be 300. I want to see the data up closely. So here's my data, and I have it plotted. So now I'm going to make a numerical model. I'm going to apply an equation. So I just left click once, only one click, and then I use the right button, click it once, and I add a trend line. And I can add any type of trend line I want, exponential, logarithmic. I'm going to add a second order polynomial. You might say, well, what is that? Well, I'm going to go down here at the bottom, I'm going to say display it, and that's what it is. And I want to do more. I want to know what the concentrations are going to be 100 years into the future. So I'll type in 100 because I'm going to forecast 100. Close. And voila, I've created a numerical model. I've taken some measured data, I fit what's called curve fitting a line, and then I projected that into the future. So what will the CO2 concentration be in your future around the time that you retire, maybe 2065? For your homework, I want to know what that number is. We can kind of eyeball it here, or I can use this equation to plug in year for my x and find out what my y is. Well, that's great, but what does that mean for pH? Well, it's the same thing. We can do the same thing. Left click, highlight both, and I insert a scatter plot. I have my figure. I left click once on the data, and then I right click and I add my trend line, and this one I want it to be linear. I'm going to display the equation on the chart. I'm going to go forward 100 years, and now I have my data, my model. And here, this is y equals mx plus b. It's a straight line coming down. And what I see is that pH in the ocean, oops, right here, pH in the ocean is actually decreasing at 0.002 or 0.002 pH units per year. So the CO2 in the atmosphere is coming down into the ocean. We have a chemical reaction that's taking place and making carbonic acid. So once again, I can use my numerical model and say, well, in 2065, that's my x. What will my y be? And that will be my pH, or your pH of the ocean, if all stays the same. And this is very simple to do. Now, of course, we can go up in complexity now, and that's what scientists do, is they go ahead and take the atmospheric CO2 data. We can calculate what the water CO2 gas data will be, and then look and say, what will be the pH of the water because of that? And we try and fit the chemistry here behind me with the data that we collect in the real world. And that today is your, I guess, homework or exercise. Now go ahead and use your calculators to calculate these numbers. Put them right there, and write down on the next page, I want to know what the pH and CO2 concentrations are, and drop it in the Dropbox. Thank you very much.